Assalamualaikum and salam UiTM di hatiku. Today we would like to present our topic entitled Application of Titration Apparatus and Techniques in Food Industry. As we saw in the opening demonstration, different fruit juices have different acidity levels. Have you ever wondered how the manufacturers ensure that every bottle of juice has a consistent taste, quality, and safety before it reaches consumers? The answer lies in analytical chemistry, where laboratory apparatus and proper analytical techniques are used to determine the acidity of fruit juice accurately. Without further ado, let's begin with the introduction. Fruit juice is one of the most popular beverages consumed worldwide. Besides providing nutritional benefits, consumers also expect every bottle of juice to have a pleasant taste and consistent quality. Before any food product is released to the market, it must undergo several quality control tests to ensure that it meets industrial standards and is safe for consumption. One of the most important parameters evaluated during quality control is acidity because it directly influences the characteristics of the product. The acidity level affects several aspects of fruit juice, including its taste, shelf life, overall product quality, and consumer acceptance. For example, if the acidity is too high, the juice may taste excessively sour. Whereas if it's too low, the flavor may become dull and the product may spoil more easily. Therefore, food manufacturers use analytical chemistry techniques such as acid-base titration to accurately determine the acidity level of fruit juice before it is distributed to consumers.
And now I'll be discussing titration, a precise analytical technique used in chemistry to determine the unknown concentration of a solution. This versatile method is commonly applied in acid-base, redox, and also precipitation reactions. The process relies on two main components, the titrant and the analyte. The titrant is a solution of known concentration, which is slowly added drop by drop from a burette into a measured volume of unknown solutions called the analyte. The mixture is continuously swirled to ensure a true reaction. This addition continues until we reach the equivalence point, which is the exact moment the reactants have completely combined according to their balanced chemical equation. Because this point is usually invincible, a chemical indicator is added beforehand. The indicator changes color at the end point, signaling the experimenter to stop adding titrant. Finally, the volume of titrant used is recorded. By using this volume alongside the balanced chemical equation, we accurately calculate the analyte's concentration because it delivers highly precise and reliable results. Titration is widely used worldwide for quality control, environmental testing, pharmaceutical analysis, and also for laboratory.
Next, I'll explain the experimental procedure used to determine the vitamin C content in the fruit juice. First, 25 ml of fruit juice was measured using a pipette and transferred into a conical flask. After that, 2 to 3 drops of phenolphthalein indicator were added to the solution. Then, the burette was filled with a standard sodium hydroxide or NaOH solution. After that, the NaOH was added slowly into the flask while continuously swirling the flask to ensure proper mixing. The titration was stopped when a pale pink color remained for about 30 seconds, indicating that the endpoint has been reached. Finally, the volume of NaOH used was recorded for the calculation of the vitamin C concentration. Accurate technique is very important in titration because even small mistakes can affect the final result. First, the burette reading must be taken correctly to ensure the recorded volume is accurate. Second, the meniscus should always be read at eye level to avoid parallax error. Third, proper pipetting technique is essential so that the correct volume of fruit juice is transferred to the flask. In addition, it is important to avoid air bubbles in the burette as they can change the actual volume of NaOH delivered. Lastly, accurate endpoint detection is crucial. The titration should stop when a faint pink color persists for about 30 seconds. Stopping too early or too late will reduce the accuracy of the result. By following these techniques carefully, we can obtain reliable and precise experimental data.
Now, I will present the result of our acid-base titration experiment to determine the acidity of different fruit juices. 3 samples were tested, which were orange juice, apple juice, and grape juice. Each sample was titrated 3 times to improve the accuracy and reliability of the results. Based on the average titration value, orange juice recorded the highest average volume of sodium hydroxide used, which was 18.50 milliliters. This indicates that the orange juice had the highest acidity among the 3 samples because more sodium hydroxide was required to neutralize the acid present. Next, grape juice recorded an average titration value of 15.70 milliliters, showing a moderate level of acidity. Lastly, apple juice had the lowest average titration value of 12.20 milliliters, indicating that it contained the lowest amount of acid. The smallest difference between the 3 trials for each sample showed that the titration technique was carried out consistently, producing precise and reliable results. From these results, we can conclude that the acidity of fruit juices varies depending on the concentration of organic acid present in each sample. Orange juice showed the highest acidity because it contains a higher concentration of citric acid, which required a larger volume of sodium hydroxide for a complete neutralization. In contrast, apple juice required the least sodium hydroxide, indicating a lower concentration of organic acids, while grape juice showed an intermediate level of acidity. During the titration, phenolphthalein was used as the indicator. It changed from a colorless to a pale pink color at the endpoint, signaling that neutralization had been achieved. This experiment also demonstrates the importance of using proper titration apparatus and techniques. Accurate readings, careful endpoint detection, and repeated trials help ensure precise and reproducible results. In the food industry, acid-based titration is widely used for quality control, allowing manufacturers to monitor the acidity of products such as fruit juices, soft drinks, dairy products, and other beverages. Maintaining the correct acidity improves product quality, ensures consistency between batches, enhances flavors, and helps meet food safety standards. Overall, titration is a simple, accurate, and cost-effective analytical method that plays an important role in food quality analysis and product standardization.
Titration plays an important role in the food industry, especially in quality control. It helps manufacturers measure acidity levels to ensure products meet the required standards. It is also used for product standardization, allowing food products to maintain consistent taste and quality across different batches. In addition, titration helps ensure consumer safety, supports compliance with food regulations, and monitors changes in acidity during storage to determine shelf life. Therefore, titration is a valuable tool for maintaining food quality and safety. In conclusion, titration is a valuable analytical technique widely used in the food industry for determining acidity levels accurately. The accuracy of titration depends on the correct use of laboratory equipment, especially burettes and pipettes, which help ensure precise measurements and reliable results. The information obtained from titration assists manufacturers in maintaining consistent product quality, meeting regulatory requirements, and ensuring food safety. Therefore, accurate titration analysis plays an important role in producing high-quality food products and enhancing consumer satisfaction. Thank you for your attention.